Hello everyone, this is the 2019 paper, physics paper 1, question 3. So our question 3 tells us that there's a stone A which is thrown vertically upwards with a speed of 10 meters per second from the edge of the roof of a building that is 40 meters high. And we can look at the diagram. And it also says we must ignore the effects of air friction and then take the ground as reference. Okay, so if we look at the picture, we can see they've drawn a nice picture for us. The building is 40 meters high. The stone's been thrown up um, with a starting velocity of 10 meters per second. And we know that what will happen to the stone is that it'll go up until it reaches a maximum height. At that maximum height, the velocity will be equal to zero. And then what will happen to the rock, to the stone, is that it will fall all the way to the ground. Okay, so now we can get started with the questions. So our first question says to define the term free fall. Okay, so the definition of the term free fall is motion during which the only force acting is the force of gravity. Okay, so no other forces are acting on it. That means that there is no air friction. Like I said here, ignore the effects of air friction. There's no air friction. The stone doesn't have a motor pulling it up or anything. Nothing else is acting on it. Okay. For question 3.2, it asks us to calculate the maximum height above the ground reached by stone A. And if you remember, I said earlier that when the stone reaches its maximum height, then the velocity of the stone will be equal to zero. Okay, that is always a rule. When you are throwing something up, the velocity will be equal to zero when it's at its maximum height, and then it'll come back down again. Okay, so now how can we do this? We look to our formula sheet for some help. Okay, and first, first of all, we need to decide which way is going to be positive. Are we going to take up as positive or are we going to take down as positive? So I'm going to say we're going to take up as positive. So, um, for instance, gravity always acts downward. So the acceleration caused by gravity is going to be negative because it's acting down. But the person is throwing the stone upwards. So the velocity of the stone upwards is going to be positive. Okay. So we need to write here for the examiner so that they know what we're doing. We're going to write here upwards is positive. Okay, and then we're going to look to our formula sheet for a formula that we can see has a lot of the things in it that we know and also has the height. Okay, so if we look at our formula sheet, the formula VF squared equals VI squared plus 2A change in Y kind of helps us out because we have the VF. So VF squared equals VR squared plus 2A change in Y. Whenever you're choosing a formula, look for the formula that you know the most information for, the formula that you can fit most of your information from the question in. So there are some other formulas that you can use. And if you go on to the memo for this question on, for example, EC exams, you can, there are quite a few different ways that they do it. Um, so you could also use the formula VF equals VR plus a change in time. Today, I'm going to be using this one. Okay, so we have we have the VF, the because that's the velocity when the height is at the maximum, and we know that that is zero. We have the VR because we have been given that in the question. We were told in the question that it's thrown upwards at 10 meters per second. That is the initial velocity, the VR. We know that the acceleration, the only thing that is acting on this ball is gravity. So the acceleration is going to be gravity. And how much is gravity? Always 9.8 meters per second minus 2. Okay, we have to remember though, we're taking upwards as positive and gravity acts downwards. So it's going to be a negative acceleration. And then our change in y is the thing that we are looking for in this question. Okay, so we can fill this in. We know that the VF squared equals 0 because 0 is always the speed at the highest point before it comes back down again. We were told that the initial velocity that the ball was thrown, that the stone was thrown up with was 10 meters per second. So we put in 10 and was thrown upwards. So it's positive because it was thrown up and we're working upwards as positive. Plus 2, and our acceleration is gravity. And the acceleration, the gravitational acceleration acts downwards. We have chosen upwards as positive, so we're going to have negative gravitational acceleration. So because it's acting downwards, so it's going to be negative 9.8, and then the change in y at the end. Okay, and we got so the change in y is how high the ball will go up. I mean, not the ball, how high the stone will go up. Okay, so now we work out some. Keep it all nice and neat for your examiner so that they can see what is going on. Okay, so this is the height from the top of the building. So all we've done is go from here to the top, from there, from the top of the building to the top of the height of how high the person threw the stone. But they're asking us for the maximum height above the ground. Okay, so we know that the building is 40 meters, right? So therefore the stone was thrown up 40 meters above the ground. So the distance that we worked out that the maximum height is 40 meters, is that height plus the 40 meters that it is above the ground already. So that's our change in y. So therefore our height above the ground is 40 meters, which is the height of the building, plus the 5,10 meters that we just worked out. Therefore, the height above the ground is 45.10 meters. Okay. Now, our next question says to us, write the magnitude and direction of the acceleration of stone A at this maximum height. So I told you in the beginning that the only force acting on the stone is the force of gravity, which we actually said in our when we defined the term free fall, because the stone is in free fall. The only force acting on it is the force of gravity. Okay. So the acceleration is gravitational acceleration. So it is 9.8 meters per second. But in what direction? So the magnitude is 9.8 meters per second. And the direction that the force of gravity acts is always downwards. Okay, so the answer for this question, we don't have to give a explanation. So the answer for this question is 9.8 meters per second minus 2 downwards. And I'm going to put here, this is always with free fall of anything because the only force acting on it is gravity. And gravity is always 9.8 meters per second minus 2 down. Okay. So our next question is our next proper big question. And it is, so they tell us stone B. We don't have a stone B here yet. Okay, so this is stone A. Now we are going to draw in a stone B. So stone B is dropped from rest from the edge of the roof X seconds after stone A was thrown upwards. Okay, so I'm going to draw stone B on the side. This is stone B. So B was just dropped. Stone A was thrown upwards. Stone A was thrown upwards. So stone A is going to do this and go down. And we know that the V on the top, the velocity on the top is 0. Yeah. But stone B wasn't thrown upwards. Stone B was just dropped. So stone B is just going to go straight down. Jeeps. Okay. Straight down to the ground. So we can see that stone A obviously traveled a lot further than B. Okay. So now it tells us stone A passes stone B when the two stones are 29.74 meters above the ground. So round about over here is when the stones pass each other. So over here, stone B and stone A are going to be next to each other. And then stone A thereafter is going to pass stone B. So they're going to meet for a millisecond at 29.74 meters above the ground. And then stone A is going to pass stone B. And then stone A is going to land first on the ground. Okay, so we must calculate the value of x. And the value of x is how many seconds after stone A was thrown up was stone B dropped. Okay, so your one friend standing on one side of the building, they threw stone A up, and then we want to know how many seconds after your friend threw up stone A did you drop stone B? Because the stones passed each other when they were both 29.74 meters above the ground. Okay, so might seem a bit tricky, but it's actually not too bad. Okay. So the thing we're looking for is the time in seconds, and we know that the height above the ground is 29.74. Okay, so the first thing we want to know is at what time, after what amount of time from when we threw up stone A is stone A 29.74 meters from the ground. Okay, so I am going to this question over here. So first things first, we always start with telling our examiner which way is positive. So we're going to tell them up is positive. That is always the first thing we tell our examiner, otherwise the examiner is going to be confused. Okay, and now we're first going to deal with stone A. So for stone A, so the distance that stone A travels from the roof to the meeting point, we want to know how much that is. Okay, so what is this distance that stone A traveled? Distance from the top of the building to meeting point. And so we can work this out by saying the building is 40 meters high and the distance from the ground that the meeting point is 29.74 meters. Therefore, the distance from the ground that, therefore, the distance that stone A traveled from the top of the building to the meeting point is 10.26 meters. From top building to meeting. Okay. And we know that, okay, so we know that the ball A was thrown up at 10 meters per second. Okay. Goes up, comes back down again. All good. Okay. So we want to know how long it takes for the ball, for the stone to go up to the distance that we calculated just now, which was 45 meters off the ground, and then to come back down to 29.474 meters. Okay. Um, yeah, so we want to know how long it took the ball to travel 10.26 meters. Okay. And so we, okay, so we know because of this arc, if the ball was thrown up at 10 meters per second over here, when it is at the same height but coming back down again, the velocity is also going to be 10 meters per second. But remember, this time it is traveling downwards, so it's going to be negative 10 meters per second. Okay. So whenever something is at the same height that it used to be, and obviously nothing could have changed, nothing changed. All the ball did was go up to that highest point and then fall back down again. So we know the velocity here is also 10 meters per second. So that's how far it traveled, and we said that was 10.26 meters. Okay. So now we can go back to our question and we can look on our question sheet for a nice formula that has time in it. It has a height in it. It has velocity, but only the starting velocity because we only have the starting velocity. We don't know what velocity it was when they passed each other. And acceleration, because you know that only gravity is acting on it, so it's gravitational acceleration. Okay. And we find that the best formula to use is change in y of stone A. So the change in the height of stone A, which we know is 10.26 meters, equal to the initial velocity times the change in time, which we don't know, plus half the acceleration times the change in time squared. Okay, so our change in y, which is the change in the height, is we know it's 10.62 meters. Great, all good and well. But it is 10.26 meters going down. We are falling downwards. This ball isn't going up, it's going down. And we have chosen up as positive. If you chose down as positive, sure, you can put 10.26 meters there. Nice. Okay. Everything else then has to change. But this ball is falling down. We've set up as positive. Therefore, the change in the distance has to be negative because we are going down. The ball is falling down. Okay. And the initial velocity is 10, as I explained earlier. We don't know what the change in time is. Half is half. Gravitational acceleration is also always down. And again, obviously, we don't know what the change in time. Okay. Gravitational acceleration always down, and we've chosen up as positive. So there we go. And now put it in our calculator, and we calculate it all out nicely. how we do that will be as so. And then we need to do factorizing. You know, make it all nice equals 0. 4.9 changing t squared plus 10 plus 2, 6. And then I'm hoping that you guys all know this is maths now, this is not physics. So you all know how to factorize all nicely. And we're going to get the answer. And the answer is okay. Remember, when you're factorizing and you get two answers, usually the one answer is positive and the other is negative. You can't have a negative time. You cannot. You cannot have a negative time. That is, you can't. So if you get a negative answer and you're looking for time, that one is not the one. It's the other one. Please, you can't have a negative time. Okay. So if we factorize this out, then we get that the change in time is 2.79 seconds. Okay, so that was the time for Stone A to go from here all the way down to the meeting point. Okay, I know that we used this velocity, but the thing is that because we had to use this height, okay, and it doesn't really make a difference to our equation. Okay, so now that is the time for A to go from the top of the building. Oh, sorry. Yes, no, that is not the time for top for. It's basically the time to go there to there. Okay, not this part. Sorry. Okay. So now we're gonna look at stone B. We're gonna write an sleeve for stone B. And we want to know what the time is, the time it takes for stone B to fall from the top of the building to the meeting point. And we know that the distance from the top of the building to the meeting point is 10.26 meters. Okay, we've done that. Know that. We can use the same formula again. And we are going to fill it in. Okay, again, we are going down. So the change in height is negative because we're going downwards. Okay. The stone B was dropped. So that means that the initial velocity of stone B was 0. And 0 times anything is 0. Okay, so the initial stone B was dropped. If anything is dropped, the initial velocity is 0. Again, only gravity is acting on it and gravity acts downwards. Um, Again, going to have to do some nice math things, and we get the change in time is 1.45 seconds. So the time that it took stone A to fall, okay, we worked out was 2.79 seconds, and stone B falling time, okay, so from this, clearly stone B was dropped after stone A because it took different amounts of times to get to the same place. Okay, so now we want to know how long after stone B was thrown was stone A was thrown was stone B dropped. So to do that, we go stone A's time minus stone B's time, and we get 1.34 seconds. Therefore, stone B was dropped 1.34 seconds after Stone A was thrown. Okay, but in the question, they asked us to calculate the value of x in seconds. So we're just going to say, therefore, x equals 1.34 seconds. Okay, that's the answer. So stone B was dropped 1.3 seconds after stone A was thrown. Okay, thank you. I hope that made sense. Um, you can go look at the memo on I know EC Exams has it the website, and there are a few different ways to do it. This is just the way that I prefer. You can make um downwards as positive. You'll just need to think about which things you need to switch. So gravitational acceleration will be positive. Um, this falling down 10.26 meters, that will be positive to be downwards. But the velocity that we started with for stone A will be negative. This will be negative if you were saying that downwards is positive because you're throwing it upwards first. So therefore upwards is negative if downwards is positive. Okay, thank you.